Alright, so in this video, we are going to discuss the May June 2022 paper 3.3, Pure Mathematics 3. Okay, so let's start with question number 1. Okay, so we are having, they want us to solve this equation that involve the ln, and then our final answer correct to 3 decimal places. Alright, so let's start. For our equation here, basically we're having all the terms with ln. So before I can cancel off the ln, or maybe I can make the ln disappear, what I need to do is like, I will need to combine all of them together first, become each side only have one ln. So the first step is the constant in front of ln, I will want to pull it back, become the power. So I will have x plus 1 squared, then minus ln x, and after that I want to apply the property for ln function, where I'm having a result or property lah, where if let's say we are having ln A over B, I can write become ln A minus ln B. And now we are going to do it the other way around. That means we are going to do it backward. From here, go back to this side. So I want to apply it here. Okay, ln something minus ln B, ln A minus ln B. If I want to combine them, it will become ln, and then x plus 1 squared divided by x. When both sides of the equation has only one ln in overall, I mean, if you have a look, you are having ln something equals to ln something for left and also the right hand side, then at this step you can try to cancel off the ln. And when we cancel off the ln, we will have this equation where I bring out the x, I bring up the x here, become multiply, then 2x minus 1, and after that I expand the quadratic. Okay, so I expand the bracket on top with the square. So I'm having x squared plus 2x plus 1. Then for the left hand side, this is what I have now. And if I try to simplify my whole equation right to one side, and I will get x squared minus 3x and then minus 1 equals to 0. So very obvious, this is actually a quadratic equation. So to solve it, to find the value for x, we can use the quadratic formula, where it should be negative b. Your b is negative 3, right? Okay, then plus minus b squared minus 4ac. b squared minus 4ac. Then divided by 2a. So divided by 2 multiply with 1. Okay, then by the help of calculator, try to get the value. By right, you should have 3 plus minus square root 13 divided by 2. And then if you try to change it become decimal number, we should have x equals to 3.303, and another value that I get will be x equals to negative 0.303. And then for this question, for this answer, I had to ignore the value where x equals to negative 303. So do you know why we need to ignore it? Okay, so before you decide the final answer, right, basically you have to check the original question. Okay, so if you have a look for this particular term, right, which is more straightforward, if I'm having ln x, where you let x equals to negative 0.303, right, if you substitute the x into the ln, which is the negative value for the x, you will get a math error. Therefore, for this question, we will ignore the answer where x equals to negative value, and we only accept one answer here, x equals to 3.303, and our answer correct to 3 decimal places. Question number 2. Okay, so they want us to expand this fraction with a square root outside, alright, in ascending power of x up to and including the term in x squared, simplifying the coefficient. So for this question, when we want to expand it in the ascending power of x, basically we have to apply binomial series formula. Okay, and then for this one, we are having the power half. So the square root here means we are having power half for the whole fraction. So when we are having power half and we want to apply binomial expansion on it, basically we should apply the formula, okay, where it should be 1 plus x power n. And then the n is rational and also the modulus x is smaller than 1. So this is the formula that we are going to use in here. Okay, so for AS level, we are having this where the n are all positive integer. So since now we are having the n power half, we should use the second formula here. And then let's go back to our notes, our question. Maybe I can try to show this formula. Okay, so for this formula, when you want to apply it, you need to take note that the first term must start with 1. Okay, so we try to rephrase our question so that we can start applying the formula here. Right, so let's start. Okay, so for 1 plus x, 1 plus 2x and 1 minus 2x, I can rewrite become 1 plus 2x and then divided by 1 minus 2x. And the whole thing with power half. So in a fraction with the power, right, you can actually separate them into the fraction, the bracket with a power half on top and also the bracket with a power half at the bottom. And then to further expand it, it will be good if we can bring the bracket at the bottom become the numerator. So when you want to bring it up, it will become 1 minus 2x with power negative half. Okay, so we are having the product of two brackets and I want to expand them separately. After I expand them, only I combine them together by multiplying each other. And before we start the question, let's have a look for the formula. Okay, so for this formula, we need to ensure that before we apply it, the first term here must be a 1 in the bracket. So let's double check. These two are first term, so no problem, we can straight away apply the formula here. And then you just need to take note for the red color bracket, the x is our 2x, okay, in the question, and then the n is power half. Then for the blue color bracket, the x is actually negative 2x in our question, and also the n is power negative half. Right, so we'll try to expand this one. So for the red color question, red color bracket, first term is a 1 plus nx, so nx will be half. For our case here, the n is half, right? And then the x is 2x. And then after that, n minus 1, so n minus 1, which is negative half, divided by 2 factorial. Then we are having x squared. So our x is 2x basically, so I'm having 2x squared. For this question, their request is until x power 2, the term in x power 2. Therefore, you can stop here because if we square this term, later we have x power 2. If we continue further, we have x power 3, where it is not needed in our answer. Then for the blue color part, also the same. First term is a 1. Second term is nx, where my n is negative half. The x is negative 2x for my question. And then I'm having n minus 1, so this is my n. n minus 1 will be negative 3 over 2, divided by 2 factorial, and bracket negative 2x squared. Okay, so we just try to put in everything by using the formula, and after that we will stop at x squared for both brackets because we don't want to have any higher power, right? Okay, so continue from here, we try to simplify all the term. For the red color bracket, I'm having 1 plus x, then minus half x squared. For the blue color part, we are having 1 plus x, then plus 3 over 2x squared. Okay, then to get the final answer, of course, we need to get all the terms that involve the constant x power 1 and also x power 2. So first of all, I have to take 1, multiply with the 1 here, I get a 1. Then first term, multiply with the second term, I get an x. First term, multiply the third term, I have 3 over 2x squared. Okay, and after that, go to the second term. So for the second term, also the same thing. X multiply with 1, I have the x. X multiply with x, I got x squared. And then x multiply with the last term here, I'll get something with x power 3. And x power 3 is not the answer that we need in our final answer. Therefore, I'm not going to multiply them. And last one, I take this multiply with the 1. So I'm having negative half x squared. Again, if I continue to expand, I will get x power 3 and x power 4, where it is not needed in our final answer, therefore I will not expand it anymore. So I will just stop here. So I just need to double check and see, okay, have I included all the terms with x squared, with the higher power x squared or not? So if yes, then you try to simplify everything here, then we'll get something like this. So for me, I'm having 1 plus 2x, then plus 2x squared. Alright, so this is how we answer question 2 by using the binomial series formula. Okay, so question number 3, they want us to find the exact value of this integration. So highlight the word exact value. Alright, and our final answer shouldn't be in decimal number, right? You should have it in pi form or maybe e form, okay, exponential form or fraction form. Okay, so if we have a look for the question here, we are having the integration, and then inside the integration we are having x and also secant square x. It is actually the product of two functions, I would say. Okay, so we are having x multiplied with secant square x. So for this kind of question, when we want to integrate it, it is a product of two functions. Therefore, we have to apply integration by part. Integration by part formula is provided in the formula booklet, where it belongs to the integration part in the formula booklet, and this is the integration by part formula. Right, and then I try to copy it back. So this is what we have here. Okay, so for this integration by part formula, this is what I copy out from the formula booklet. Alright. Okay, so this is what I copy out from the formula booklet, and then usually for me myself, I'm using it in a more simplified version, where I try to simplify the dx with dx, and then eventually my equation will look something like this, where I'm having a more simple equation. Integration of u dv equals to uv minus v du. And usually I'm referring to this one, the more simplified version. Alright. Okay. And then to decide which one is u and also which one is the integration of dv, we need to follow the Liat rule, right? L-I-A-T-E. So maybe I write here L-I-A-T-E. Okay, if you have a look for the question here, A is algebra, right? And then the secant square is basically referred to trigo, so A and T, trigo. So for us, we know that when you are having the higher group, then it will become the u, the lower group will become the dv with integration, right? And then since we are having A is a higher group and then the T is a lower group, therefore what do we have here is our u is actually equals to the x. And then the integration of dv basically is equals to the remaining part, integration of secant square x dx. And integration of dv here, actually there's a number 1, just like we didn't write out, so it should be integrate 1 dv equals to secant square dx, right? Okay, so first of all, before we apply all the formula here, we try to identify the u and also the dv first, and then we will try to carry out the steps. So for the u part, we try to find out the differentiation, du dx equals to 1 for this case, and my du is equals to dx. For the integration part, integrate 1, I get a v, integrate secant square, I got tangent x. So please take note that I didn't put any plus c here because this is not the final step for integration yet. So usually I will just put a plus c at the very final step inside the integration. Okay, so once we decide all the details already, which one is the u and which one is the integration of dv, then we can start the integration by part. For integration by part, we copy the question first. According to the formula, right, basically this question is actually our left hand side, and then equals to uv. So what is the u? U is equals to x. What is your v? V is equals to tangent x. And then uv, you have to put in the limit, which is pi over 4 and also 0. Then minus, can you see the minus here? So we just copy the minus. Okay, this is minus, and we copy the minus in our solution. And then integration, I just copy the integration. Of course, the limit still remain. Okay, then we integrate v. What is the v? V is tangent x. And then what is du? So du basically is equals to dx. Alright, and then let us continue further for this part. Substitute pi over 4 into the x. I'm having pi over 4 and then tangent pi over 4. Then minus 0, because if you substitute 0 here, the whole term becomes 0. Okay, so for the integration at the end, we try to relate how to integrate tangent. So by right, if you have the idea for f prime x over fx, tangent can be written as sine over cos. Okay, and then if you try to differentiate the cos, if let's say I let cos x equals to function fx, then when you differentiate the cos, you should have negative sine x. Okay, so for the numerator here, I should have a negative sine x so that it becomes the f prime x over fx pattern. Okay, I need to have a negative sine x. So when I want to have a negative sine x outside, I also need to multiply negative so that it becomes balanced. So when I want to make it become balanced, negative multiply with negative, it becomes positive. Okay, so again, this part already become f prime x over fx pattern, and we can further simplify. Okay, so let us continue back. For the front part, tangent pi over 4 is a 1, therefore I get pi over 4 here. And then for this integration, I want to integrate f prime x over fx. So there's one formula about f prime x over fx also in our formula booklet. So you can see this f prime x over fx integration, I'll get ln fx. Same thing happened here. Currently, we are having f prime x on top over fx at the bottom. When we try to integrate it, we will have ln fx. So my fx is actually cos x. And then I want to put in a limit as well. I cannot ignore the limit, so I'm having pi over 4 and also 0. Okay, next step. Try to substitute in the pi over 4. So I'm having ln, then cos pi over 4 minus ln cos 0. Okay, next step again. We are now going to try and simplify all the terms here. So what is the value for cos pi over 4? So if we try to simplify it, I will get cos pi over 4, which is 1 over square root 2. You can write 2 over square root 2 over 2 also can. Then the value for cos 0 is a 1. Okay, then continue to simplify. For this part, ln 1 over square root 2, I can actually rephrase it become ln 1 minus ln square root 2. This particular term, I can write become this one because I'm using the rule where ln A divided by B can be written as ln A minus ln B. Okay, and then the last term here, ln 1, is basically a 0. So you know that ln 1 is 0 here. This one is also a 0 later. Therefore, if you try to simplify it, I will have negative is still a negative, right? Then for the power half, I will want to pull it in front. And therefore, I'm having pi over 4 minus half ln 2. So I think this is the simplified answer that I can have. And I keep my answer in a pi form and ln form so that it is actually the exact value for the integration. Okay, then for your information, this one to this one, it is because I'm using ln x power a can be written as a ln x. So since the square root is power half, right? So I can pull the half in front, and therefore I'm having half ln 2. Okay, so this is how we solve question. Okay, we come to question number 4 now. We are having parametric equations, and then the t is defined from 0 until 90 degrees, which is pi over 2. So first of all, they want to show that the dy dx equals to cotangent t. Okay, so before I can find out the dy dx equals to cotangent t, I need to apply differentiation on both equation x and y separately with respect to t. Okay, so this is my original equation for x. I want to find out the dx dt. So differentiate 2t, you get a 2. Differentiate tangent, you get secant squared. Alright, so if let's say you already forget how to differentiate tangent, you can get it from the from the formula booklet. Under the differentiation part, you can see that differentiate tangent, you get secant square. And then for the value of y, for the equation of y also the same. I try to differentiate it. So y is equals to ln and then sine 2t. To find out the differentiation for y, okay, so we are having the main function which is a ln. So to differentiate the ln, you bring the bracket down, become the denominator. And after that, you differentiate the thing inside the bracket. Differentiate sine, you get cos. And after that, differentiate 2t again, you get 2. So by right, we are having 2 cos 2t over sine 2t for my dy dt. Okay, after I find out the dx dt and dy dt already, to get dy dx, we need to apply chain rule. So dy dx will be dy dt multiply with dt dx. Okay, and now we should continue to solve and simplify it. Okay, so before you simplify, right, let's have a look for our final answer here. Our final answer here is cotangent t. T is 1t. 1t means a single angle. Right, and then in my dy dt and also dx dt, okay, this one I have d which is the single angle, but for dy dt I'm having cos 2t and sin 2t, which means that for this part I may need to expand the formula using the double angle formula. Okay, because we are having double angle here, double angle t. Right. Okay, so maybe we can try to solve it and simplify slowly. Okay, so first of all, we are having 2 cotangent 2 cos 2t divided by sin 2t multiply with dt dx. So if I multiply with dt dx, I'm having 1 over 2 minus secant square t. Okay, so that's the first step that I have. And after that, to further simplify, I understand that we need to expand the cos 2t and sin 2t by using double angle formula. Okay, so for sin 2t, the formula is very simple. We are having 2 sin t cos t. This is a double angle formula provided in the formula booklet as well. And then for the cos 2t, we are having 3 options. We are having 2 cos square t minus 1. We are having 1 minus 2 sin square t, and also we are having cos square minus sin square. Okay, so we try to analyze it slowly, right? I'm having a 2 here, right? 2. And then for cos 2t, we can have a lot of options here. And then if I try to have a look in detail, right? I have no idea yet what is the cos 2t that I should expand. Okay, so some students might say that, oh, I just choose anything, then only I simplify slowly. Or maybe you can try to keep until maybe a few more steps, then only you decide which formula of 2t that you want to use and expand. Alright, there's no correct or wrong. Okay, maybe for me, I will just keep it first. Then for sin 2t, I will make it become 2 sin t cos t . Okay, so this one I just keep it as cos 2t first because I actually have no idea what should I do so that I can simplify with my other terms. So I just keep it first. Okay, then for the second bracket here, I'm having 2 minus secant square. To simplify it, I will make the secant square become cos square t first. Because if we have a look for all our answer here, the secant square doesn't appear in my final answer. My final answer is cotangent t, right? So secant square doesn't appear inside the answer. So I will want to change it become cos square and see how can we simplify it. Okay, then simplify the 2. Cos 2t, I just copy, I don't touch it yet. And then I'm having sin t cos t. Okay, for this second fraction here, right, I realized that it is quite troublesome for me if we have a fraction inside the fraction. So for this one, if I want to make the fraction disappear, I multiply it with cos square t. If I multiply the denominator with cos square t, the numerator also I need to multiply with cos square t. Okay, so when you multiply them, you are having cos square t on top, and then I'm having 2 cos square t at the bottom, then minus 1. Okay, so just a reminder, for the cos square t at the denominator, you have to multiply into both terms in the bracket. Okay, so this is what we have for now. And after that, we further analyze again. Cos t and cos square t can be simplified as well. Okay, and then what should I do with the cos 2t? So I think now you can see very clearly, cos 2t can be written as 2 cos square t minus 1. So this is also 2 cos square t minus 1, and it can be simplified with this term. They are the same actually. Okay, so I think until this time you can see the answer is out very clearly. So we are having this term eventually, cos t divided by sin t, and you can further simplify, become cotangent t. Alright, so this is how we solve this question number 4. Question number 5. On the sketch of an angle diagram, they want us to shade the region whose point represent the complex number z and satisfy the inequality. There are two inequalities here. The first one is this, and the second one is this one. Okay, so usually before I start sketching the inequality, I will want to make it become a standard form where the modulus of z minus a complex number should be smaller or equals to 2. So the complex number here, according to what we have inside, it should be negative 2 plus 0i. And after we rephrase it like this, basically you know that it is a circle with the center negative 2, 0, and then the radius is a 2. And then for this one, I am z greater equals to 1. Imaginary part of z basically means y also. So you're having y greater equals to 1. So now we start to sketch these two equations here. These two inequality here, sorry. So I'm having negative 2 and 0 as a midpoint. So what am I going to do is we try to draw the ratio out. Then maybe I put this as negative 1, negative 2, negative 3, and so on. And then for this part, 1, 2, we try to make the ratio similar for x and y so that it looks balanced. Okay, my midpoint is at 2, negative 2 and 0. So this is my midpoint. And then my circle will pass through this one here, 2 unit, right? So this and this. So you try, if can, you try to make the ratio same for the both x and y. Okay, so continue. Then this is a circle that I have. Alright, my circle doesn't look nice, okay, because I think the ratio here is a little bit out. So for you, if you can, try to make the ratio for the x and y axis on the scale, which is having the same ratio or the same, so that your circle looks like a circle. Okay, and then after I sketch it, because I know that for this one they are looking for smaller equals to 2. So the area of the circle where smaller equals to 2, that means that the distance from z to negative 2 and 0 is less than 2 units. So that means it should be something inside the circle. Alright, so for the first inequality, we will shade the whole area inside the circle. And then now for the second inequality, I'm trying to sketch the line y equals to 1. So for y equals to 1, basically we're having this one. This is the line y equals to 1. And then they say you should have more than y equals to 1. So the overlapping area for these two inequality will be this side. Okay, so this is my answer for part A. After you shade the, after you sketch the two locus, please make sure that you shade the area that fulfill both inequality. Continue to part number B. They want us to find the greatest value of argument z for the points in the shaded region. So again, they are talking about the greatest value of argument z. So argument z means that they want to see the argument that we try to measure from 0, 0, okay, to the locus z. Right, so if we want to get the greatest value for the argument z, of course we need our diagram to help us. Okay, so I will refer back to the diagram. 0, 0 is this point. And then to get the greatest argument, definitely this should be my z. Okay, this is 0, 0. It is because of, if we try to calculate the z here, this argument will be the biggest one. If my z is in front, you can see that the argument is actually smaller, right? Okay, yeah, so my z should be at the end, okay, of the area. This is my z, and then to calculate the argument, we need to find out some you need to think how to actually find out the coordinate for z if possible, okay? Or maybe some student will tell me that they are trying to use the triangle or anything to help us, but from here I can't see any related triangle for now, right? So if you want, you can have a try to observe that is there any triangle or the property of circle that can help us to find out the z. But for me, what I'm going to do now is, I know that the y coordinate is 1 for the z, because it lies on the line y equals to 1, right? And after that, for this particular circle, I actually can form the circle equation. I know the midpoint. I also know the radius, right? Okay, so the midpoint is -2 and 0. Therefore, when I want to form the circle equation, it will be x plus 2 square, then plus y minus 0 square equals to radius square. So radius is a 2, and then I square it. This is my circle equation, and it is a first equation. And then my second equation, I can assume that y equals to 1, because the z, you can see that it is located on the line y equals to 1. Or you can try to think in that way, where the z is basically the intersection point between y equals to 1 and also the circle. Since I already formed the circle equation, I have the equation y equals to 1. I can solve these two equations simultaneously, which means I will substitute y equals to 1 into the circle equation, and this part I'm having a 4. Okay, then to get the x plus 2, I'm having plus minus 4 minus 1 is a 3. So plus minus square root 3. Therefore, the value for x that I have here should be negative plus minus, negative 2 plus minus square root 3. Okay, and then from here, right, if you want to further analyze it, I'm having two value of x. So one value of x is negative 2 plus square root 3. Another one will be negative 2 minus square root 3. Okay, so these two coordinate x are basically the intersection point. So you can see that for our diagram here, we are having two intersection points. So that means the negative value, negative 2 plus square root 3 should be belongs to the first intersection point here, and the z should be this one. Okay, so the coordinate for x coordinate for the z, so the x coordinate for the z in our diagram should be negative 2 minus square root 3. Okay, so from here, I actually know that my z is a complex number with the coordinate of negative 2 minus square root 3, then plus 1i. Okay, so this is my z. And then how can I calculate the argument of z? So this argument of z is in the second quadrant. Alright, to get the argument of z, since it is in the second quadrant, so the formula should be 180 degrees, which is a pi, minus the basic angle. So the basic angle for this one, I'm taking 1, which is the coefficient for I, okay, 1, divided by x. Okay, so the x here, I only want to take positive value, where it should be 2 plus square root 3. Okay, so to get the answer of argument in the second quadrant or any angle in the second quadrant, basically it should be 180 minus the basic angle. And the basic angle, we should ignore the negative value. So I change it become all positive. Then I minus each other here. By right, if you press calculator, you might have 11 pi over 12. Or for those who are using MS calculator, maybe you get a long decimal number. So if you cut it short into 3 significant figures, it will be 2.88. And this is how we calculate the argument of z. This is the greatest argument of z in the area that we shown on the Argand diagram just now. Okay, so we come to question number 6. They want us to solve the quadratic equation. I think they give us a very obvious hint because of the word quadratic. So giving an answer in the form of x plus yi, and then where the x and y are real. Okay, so to solve for this quadratic equation, we can actually use the formula for the quadratic formula to get the value for x or z lah. Alright, okay, so we are having the general formula where z equals to negative b plus minus b squared minus 4ac, then divided by 2a. Okay, then from here I try to apply what we have here. So our a is 1 minus 3i, the b is negative 2 plus I, and then the c is actually a 1. Oh, sorry, it's actually the I. Okay, so try to substitute everything in. So I'm having negative b, where I will get negative 2 plus I. This is negative b, plus minus b squared minus 4ac. So I'm having negative 2 plus I square minus 4ac. Then divided it by 2a. Okay, so it looks like very complicated, and we just need to be careful when you want to simplify all the terms inside. Okay, so if I simplify, the negative become positive, and then when I try to square the 2 plus I square, I will have 4 plus 4i and then minus I square, plus I square, which is minus 1. Okay, then I multiply the I into the bracket. I'm having I plus 3, then divided by 2, 1 minus 3i. Okay, then next step, further simplify again. Okay, if I multiply the 4 inside and then simplify the whole thing, I will actually get negative 9 here. Okay, so next step again, for the negative 9, right? Square root negative 9. Okay, so square root negative 9 can be written as square root 9 multiplied with negative 1. So eventually you are having 3i. So square root 9 is a 3, square root negative 1 is a I, right? So eventually you are having a 3i here. Okay, then what do I have here is I'm having two answers now. One is 2 plus I plus 3i divided by 2, 1 minus 3i. Another answer will be 2 plus I minus 3i, then divided by 2, 1 minus 3i. So I'm having two answers here. And if we continue further, I will have 2 plus 4i divided by 2, 1 minus 3i. Then for this part is 2 minus 2i. Okay, so from this step onwards, you can see that we try to simplify the 2. Okay, then this one also the same. And our final answer, of course, we cannot leave it in a fraction form with the complex number at the bottom, right? Therefore, we need to further simplify it by rationalize the complex number. So after I simplify, I'm having 1 plus 2i, then 1 minus 3i. To rationalize it, what do I need to do is I have to multiply the term, which is the same as denominator. Which is the same as denominator, but we change the sign of the imaginary part, which is the conjugate. Right, so I multiply with 1 plus 3i and 1 plus 3i here. Okay, then after that, I will have, for the other answer, this part I'm having 1 minus I divided by 1 minus 3i. Again, you have to rationalize it to get the most simplified answer at the end. So I multiply with the conjugate of 1 minus 3i. Okay, then Continue further. Next step, try to expand everything and simplify. So for the first answer here, I'm having 1 plus 9, then 1 plus 3i plus 2i. 3 times 2 is a 6. With I squared, it becomes negative 6. For the second answer, I also have 1 plus 9, then 1 plus 3i minus I. The last term here is negative 3 with I squared, so it will become positive 3. Alright, then again, further simplify it. Simplify the real part with the real part, imaginary with the imaginary part. We will have these two answers at last. And of course, we can still further simplify it. Then eventually, I'm having negative half plus half I, and also 2 over 5 plus 1 over 5i. So I think cannot be simplified anymore, right? This is the most simplified answer. Okay, therefore the complex number z will be this one in the particular quadratic equation that is shown us just now. Question number 7. They want us to show that this particular equation can be expressed become this one. Alright, so before we can express it become r cos x plus alpha, right? We have to ensure that all our terms in the equation can be changed into sine and cos. Right, so we have to rephrase our original equation first so that we can further simplify become this pattern. Right, so let's start. We are having square root 5 secant x and then plus tangent x equals to 4. Again, I will want to change all my trigo become the expression with sine and cos only. So secant x means that 1 over cos. I'm having square root 5 over cos x. For tangent, I'm having sine over cos, and that equals to 4. Multiply the whole equation with cos x, then this is what I will get. Square root 5 plus sine x equals to 4 cos x. Alright, and after that, you can see that we want to keep the square root 5 on one side, then the rest we can move it to the other side. If we rephrase it, then we will get 4 cos x minus sine x, then equals to square root 5. And now we are going to change this particular part into the r cos alpha x plus alpha. Okay, so to get it into this pattern, there's a standard formula that we can use where r is actually equals to square root of a square plus b square, where you should know that the a is the coefficient of cos x and then the b is the coefficient of sine x. Okay, and then to get the alpha, alpha is tangent inverse b over a, but we ignore all the negative sign. It is because of it is given inside the question that alpha should be between 0 until 90 degrees. And if you want to get the alpha in the first quadrant, of course we should remove all the negative sign. So this is a general formula for r and also the alpha. So we can start to calculate the r. R will be equals to the square root of a square plus b square, which is 4 square plus 1 square, or negative 1 square. By right, we should have square root 17 for this question, for the r. And then to get the alpha, it should be tangent inverse b over a, and it should be 1 over 4 tangent inverse. According to the question, right, they actually want us to write our answer for alpha correct to 2 decimal places, and the value for r should be in exact value. So r, I will keep it as square root 17, and then for the alpha, I need to keep it into the 2 decimal places answer. It should be 14.04 degree. Okay, therefore, you can see very clearly that the original equation where it is square root 5 secant x plus tangent x equals to 4 can be rephrased as this equation, square root 17 cos x plus alpha, which is 14.04, equals to square root 5. And this is our part A. Okay, then let us continue to part number B. For part number B, they want us to solve this equation, and then x should be from 0 until 180 degree. Okay, if we try to compare the equation in part B with the equation in part A, right? For part A, our x is actually x. Our 2x here in part B is originally x in part A. That means when I want to solve this equation, I can use the result in part 1. Okay, where I will get square root 17 and then cos. In part 1, we're having x plus 14.04, but now because it has changed the x, angle x become 2x in part B, therefore my cos angle here should be also 2x plus 14.04, and then equals to square root 5. Okay, so a general guideline, if let's say x is between 0 until 180, right? That means for 2x, basically we should try to figure out the answer from 0 until 360, which is you have to go through one cycle, okay, one round, right? Okay, so we can try to further solving this question. Okay, I'm having 5 over 17 square root, and then I want to get the basic angle first. So to get the basic angle, we are taking cos inverse square root 5 over 17. So what do I have from here? Our basic angle is actually 57.16. Okay, then now we want to get the answer for this. Okay, then like what I mentioned earlier just now, because we are having 2x in our solution, so when we want to go through the quadrant, we should go through all the 4 quadrants here. Alright, so for the first quadrant, we are having basic angle theta. Second quadrant is 180 minus basic angle. Third quadrant is 180 plus. The fourth quadrant is 360 minus. And then this is all sine, tangent, cos. And then before we look for the final answer, right, we are looking for cos value, which is positive. So we are looking and focus on the quadrant where cos is positive. So in the first quadrant, is it cos positive? Yes, right? So I want the answer from this quadrant. So to get the answer from this quadrant, it is theta, which is basic angle. So 57.16 will be my answer. Second quadrant, I don't accept the answer because cos is not positive. Third quadrant also cos is not positive. And the fourth quadrant, cos is positive again. I want to get the answer from here. So to get the answer from here, you take 360 degree minus the basic angle 57.16. You will get 302.84. Okay, so the general guideline here shows that we already go through the one cycle. Okay, so we can slowly find out the value of x. So to find out the value of x, you move 14.04 over, then after that divide your answer by 2. Okay, so if you didn't do any careless mistake on this part, basically your x should be 21.6 and also 144.4. Alright, so this is how we solve question 7. Question number 8, we have a curve like this, and then they tell us that it has a stationary point at x equals to p, where p should be greater than 0, and they want us to show that p equals to this one. Okay, so the keyword here will be the stationary point, and usually when you want to find the stationary point, we will need to find out dy dx for the equation first, and after that we let it equals to 0 and we solve it from there. Okay, so we will start from our equation here. We are having an equation in fraction form. So for the differentiation, you can either use the quotient rule, or if you don't want, you can bring the e power x minus 1 go up, become the whole bracket with power negative 1. Then you apply product rule also can. Okay, so for me, I will apply the quotient rule. Okay, so when I want to apply the differentiation in the quotient, okay, the denominator I have to square bottom, I square bottom, copy the bottom expression, differentiate the top. So differentiate the top, I'm having 3x squared, then minus, copy the top, differentiate the bottom. So differentiate the bottom e power x, I still get e power x. Differentiate negative 1, I get a 0. Okay, and this is what I have after I apply the differentiation by using the quotient rule. Okay, so next I will let dy dx equals to 0. When I let dy dx equals to 0, it already tells us that the coordinate is actually the p. Therefore, what I do is I will try to change all the x become p. That means when x equals to p, the dy dx is equals to 0. Okay, if I move the denominator up, I will have only the numerator on top Okay, so for the numerator on top, what I can do is I realize I can factorize out the p square. Okay, I can factorize out the p square. If I factorize out the p square, then I have 3 e power p minus 1 minus p e power p. Okay, then what should I do? Basically, I need to slowly rephrase my equation here so that eventually I will get the answer that they want us to show. Okay, when we factorize out the p squared, p squared equals to 0, therefore p equals to 0 and then we have only the right hand side, this one, this big bracket equals to 0. So I will let 3 e power p minus 3 minus p e p equals to 0 here. Okay, and if I try to observe this part, right, I realize that they move every terms with the 3 to the right hand side. So what am I going to do now is I try to keep p power p times e power p on one side, then I have 3, then minus 3e power p. Okay, divide the equation by using the p. Sorry, I think I made a careless mistake here, right? Because if I move this p multiply with e power p become positive and move it to the right, so the term on the left should be still the same, where I still have 3 e power p minus 3. Okay, then I want to divide everything by ep. I bring the ep over, then I have a 3, then minus 3 over e power p, and if I further rephrase it, then you can see that basically this is how we get the answer that they want us to show. So we are having p equals to 3 multiplied with 1 minus e power negative p. Alright, so this is our part A. Then continue to part number B. For part number B, they want us to show or verify by calculation that p lies between 2.5 and 3. Then for us, we want to apply the sign change rule. To get the sign change rule, first of all, you need to have a look for your original equation for p first. So in part A, we know that our equation of p is something like this. Okay, so to get the sign change, we need to move all the terms to only one side. So that means I let function, sorry, shouldn't be x, so should be a p, right? So I will let function fp equals to this, then minus p. I bring the p over. I have to move all the term to one side so that I can get the sign change. Okay, and then now I substitute 2.5 into the function and also 3 into the function. If you substitute 2.5 into the function, then basically the value that you get should be 0.254, correct, to 3 significant figure. And if you substitute 3 into this equation or this expression, you will have negative 0.149. So I think it's quite obvious, right? You can see f2.5 is positive, f3 is negative value. Therefore, you can see the sign change. So sign change can be seen. When you can see the sign change, it actually means that the root or the p lies between 2.5 and 3. Between 2.5 and 3 here. Okay, Then continue further. This is sign change. Then for part number C, they want us to use the iterative formula based on the equation in part A to determine P correct to 2 decimal places, give the result to 4 decimal places. So again, I copy back the iterative formula in part A lah. So we are having P equals to 3, then 1 minus PE power negative P. So I should have an initial value first. Okay, so to decide the initial value, for this question, they didn't give us any detail. You can just refer to the second part. You can use any value that's close to the values they ask us about the sign change. Right, so you can either take the initial value, which is 2.5. You can take the initial value, which is equal to 3. Or maybe if you want, you can take the initial value between any of these two number also can. Alright, it is just a guideline. Alright, you can actually try to find out the initial value from here so that your iteration later might not be too long. Okay, so for me myself, I'm finding out the center of between 2.5 and 3, so I'm using my first value, which is equals to 2.75. So to get the second value for the P, it means that I need to substitute 2.75 into the right hand side of the formula. And my iteration here should be written correct to 4 decimal places. We can use the calculator to help us. Okay, by key in the formula. So I'm having 3 with bracket, then 1 minus E. This is the E. Then power negative P. So I put it as power negative X. And then close bracket. Alright, then to get the iteration, you press calculate first. They're asking you what is the first value that you want to key in. So for me, I'm using 2.75. Okay, then from here you get 2.8082 blah 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 blah. And my answer, my iteration, I only want to keep it for 4 decimal places. So for 4 decimal places, it will be 2.8082. So I will write 2.8082. Then how about for the next value for P3? So for the P3 value, you repeat the process again. Press on the calculate and then key in the value for the second P. Second P is 2.8082, right? So I key in 2.8082. And the value that I get now is 8191. So I write 2.8191. Okay, so when should I stop again? So to get the root or to stop the iteration process, basically you have to double check your answer with 2 decimal places. So like for this one, if I change it become 2 decimal places, it will be 2.81. And then for this value, it should be 2.82. And you can see that for the 2 decimal places answer, they are not repeated yet. So you have to continue until the 2 decimal places answer are repeated, which means that you have to further find out the next value for P. So press calculate again, key in the value 2.8191. Next value will be 2.8210. So I'm having 2.8210. Okay, if you double check the 2 decimal places answer for this one, it is 2.82. But you can see that the value are repeated already. Then for me myself, usually I want to make it safe or to make it confirm. I usually will go through with maybe extra 1 more iteration. Alright, so now the P5, press calculate again, then 2.8210. And I will get 2.8214. So 2.8214. So again, if you double check the 2 decimal places answer for this one, also 2.82. So it is repeated for 3 times already. Therefore, I can actually conclude that the root or the P should be equals to 2.82, correct to 2 decimal places. Alright, so basically this is how we carry out the iteration process to find out the root for a particular equation. Okay, so we are now at question number 9. with respect to the origin O, the position vector of the point A, B, C are given by this, okay? So the midpoint of AC is M, and then the point of N lies on BC, so that Bn equals to 2NC. And they want us to find the position vector of M and also the N. Right, so from here we know that the M is the midpoint of AC. To find the midpoint, I will strongly suggest you to use the coordinate geometry method to find the midpoint before you change it become the position vector. Alright, so if I want to get the coordinate for M, basically you should take x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. So I'm having AC, right? Midpoint of M is the midpoint of AC. So I will take the x for A and also the x for C, where I'm having 0 plus 4 divided by 2. And then the y coordinate will be 5 plus negative 3 divided by 2. And also 2 plus negative 2 divided by 2. And from here, I can get the coordinate for the M, for the point M very easily. And I will get 2, 1, and 0. Therefore, I can straight away change the coordinate M become the vector form, which is the position vector of M, OM. So the OM will be 2i plus j. Alright, and after that, to find out the position vector of N, we should try to use this formula. Bn equals to 2nc, and I will try to change this become the vector. I'm having Bn equals to 2 times of nc. Bn can be written as Bo plus On equals to 2 times of nc, means No plus Oc. Okay, then I try to change everything into the position vector formula. Okay, so I'm having negative 2On plus 2OC. To get the position vector for On, I group all the On together. And I'm having OB plus 2OC. Then I will substitute in the position vector for OB and OC here. So the OB is this one and OC is this, right? Okay, so I'm having 1, 0, 1 plus 2 times of OC. So what is OC? OC is 4, negative 3, and negative 2. And we need to multiply with 2. So 4 will become 8, negative 3 will become negative 6, negative 2 will become negative 4. And from here, you can see very clearly that our ON is actually, our 3ON is actually 9, negative 6, and negative 3. Okay, so further simplify to get the ON, I need to divide the vector on the right hand side by 3. Alright, 3ON equals to this one, therefore ON will be everything divided by 3. And we are having 9 divided by 3, I get 3. So 3i, then minus 2j, minus k. Okay, sorry. Alright, so this is how we get the position vector for OM and also ON. Then let's proceed to part number 2. For part number B, they want us to find the vector equation for the line through M and also N. To get the vector equation, we can have a look for the detail first. So this is a line, and then this line passes through the point M and also point N. Okay, so first of all, to form the vector equation, we need the direction of the line and also the passing point of the line. For passing point, we have, you can use either the OM as passing point or ON as passing point, no problem. We have 2 passing point here. For the direction of the line, you can either find out MN or you can find out NM also can, no problem. Alright, so for me, I'm using MN. So to find out the MN will be MO plus ON. Okay, the value for MO should be, you should multiply negative inside because it is the opposite direction. So negative 2, negative 1, and 0. And then plus ON. So what do I have for the ON here? I will have 3, negative 2, and also negative 1. So this is the direction for the line, MN. Okay, I'm having 1, -3, and also -1. After I get the direction, and I already have the passing point, right? The position vector for the passing point. Therefore, I can get the equation, the vector equation for this particular line. Okay, so let me rewrite it again. So what is the vector equation here? Vector equation. The vector equation formula will be R equals to A plus dP, right? Where the A is the passing point and then the P is the direction of the line. So for this case, for the passing point in this line, right, you can use either the position vector for the M or the position vector for N. Either one also correct. So for the M is 2, 1, 0. For N is 3, -2, and -1. So up to you. So for me, I'm using 2, 1, 0. This is the passing point. Then plus T and then the direction of the line. Direction of the line, just now I already find out which is MN. And it is 1, -3, and also -1. Basically, our vector equation for MN looks something like this. Okay? Then how about for the next part? For part number C, they want us to find the position vector of Q where the line MN intersect through the line AB. Okay, so just now we have the MN line, the line MN, and then we know that if the line MN intersect with the line AB, then the intersection point basically is the Q. And we want to find the position vector of Q. Okay, so to find the position vector for Q, when we are having the Q is intersection point. So basically, if we want to find the Q, we have to solve the vector equation simultaneously to get the Q. Alright. So first of all, I need to find the equation, vector equation of AB first. So to find the equation, vector equation for AB, I need to find the direction of AB. So AB means AO plus OB. Right, where AO should be 0, -5, and -2. Then plus OB. What is OB here? OB will be 1, 0, and 1. It is given in the question, right? Okay, so my AO plus OB, I will get 1, then -5, and -1. This is the direction of the line AB. And to form the vector equation, again, I'm having R equals to A plus TP. This is a general formula. So again, what is the A? A is the passing point for this particular line. You can use either the coordinate for A or coordinate for B. Alright, so for me, I'm using maybe B lah. Okay, so I'm having 1, 0, 1, and then plus, instead of P, maybe I will use some other letter so that it won't confuse with the previous vector equation. So I use the S, and then the direction of this line is AB, which is 1, -5, and also -1. Okay, so we have the second vector equation now. Just now in part number B, we get the first equation, vector equation, and now we are having the second vector equation. To find the intersection point, we solve the equation simultaneously. Okay, so how to solve it simultaneously? So for this AB equation, if I try to combine everything together, I'm having 1 plus S, 0 minus 5S, and then 1 minus S again. And then I go and retrieve back the equation for the MN. So for MN, this is what we have. 2, 1, 0, and then you combine it with T for 1, -3, and -1. Okay, so I'm having 2, 1, 0. And you combine that, it will become 2 plus T, then 1 minus 3T, and also -1 minus T. 0 minus T. Okay, so from here, what we can see is like we are having 3 equations. So we are having equation number 1, 2, and 3. I will treat this as equation number 1, and then this one is equation number 2. If I write it out again, my equation number 1 and number 2 will be something like this. 1 plus s equals to 2 plus t. This is the equation number 1. And then 1 minus s equals to 0 minus t. This is the equation number 2. Okay? And then, wait, did I do any careless mistake here? Let me figure it out. Okay, so let me double check now. 1, negative 3, and negative 1. So the value here is 0. Oh, okay. Alright, so just to confirm it is correct. If I try to put 1 and 2 in as the first and the third equation, right? Because I realized that if I try to solve this, I can't get the answer. I will have the equation where 2 equals to 2. So maybe I have to try and change to another equation. So maybe this is the first equation again. So first equation, I'm having 1 plus s equals to 2 plus t, where s can be written as 1 plus t. And now I make this as a first equation. And then for the second equation, maybe I refer to this one, where I have negative 5s equals to 1 minus 3t. And I will make this as a second equation. To solve these two equations simultaneously, I substitute equation number 1 into equation number 2. If I substitute 1 into 2, then basically I'm having negative 5 and then 1 plus t equals to 1 minus 3t. And I try to solve for the value of t. Okay, negative 5t, move it over, I'm having positive 2. And then the 1, when I move it over, I'm having negative 6. Therefore, the t should be equals to negative 3. Once we get the value for either the t or s, you no need to find out both actually, because they're asking for the position vector for the intersection point, right? As long as you get one value, either the t value or the s value, you already can get the intersection point. So to get the intersection point, it is the position vector for q, which is OQ. So to get the OQ, you substitute t into the equation here, into the whole equation here to get the coordinate for the q. So 2 minus 3, I get negative 1. Okay, so 1 minus 3 multiplied with negative 3, I have 10. And then 0 minus negative 3, I get a positive 3. And basically, if you rewrite your position vector for q again, it will be negative I plus 10j and then plus 3k. Okay, so you can see that we are trying to solve the simultaneous equation for vector equation, okay, to get the intersection point for these two lines. Now we are at question number 10. There's a gardener filling an ornamental pool with water using a hose that delivers 30 liters of water per minute. So this is one important information here, where the gardener fills the pool with 30 liters of water per minute. So this is actually a rate. Initially, the pool is empty, so this will be the initial value. And then at the time t after filling begins, the volume of water in the pool is v liters. So the pool has a small leak and lost water at the rate of 0.01 v liters per minute. So you can see that we are having the waters fills in into the pool with the rate, which is 30 liters per minute. And after that, we are having a small leak, which is 0.01 v liters per minute. Alright, so the differential equation satisfied by v and t is in the form of this one. They want us to write down the constant a and b. So by right, according to what we understand here, they are talking about the rate of change about the volume of this pool. Okay, so when we are talking about the rate of change, basically it should be dv over dt lah. Alright, we are talking about volume, alright, so it should be the v, and then over the time it should be dt. And then since we know that we are having the waters flow in, which is 30 liters per minute, so I'm having 30 positive. Alright, and we are having a small leak at this rate, So I have to minus this leakage, it will be 0.01 V. So compared to the differential equation that they show us here, very easily you can see that A is basically 30 and B is equals to 0.01. Okay, and then now let us proceed to part number 2, part number B. So for part B, they want us to solve the differential equation and find the value of t when V equals to 1000. So there are two parts for this question. First one, we have to solve the differential equation first. Let's have a look for the differential equation. We are having dv over dt, which is equals to 30 minus 0.01 V. So for the first step, before we solve the differential equation, we have to separate the variable, the same variable, everything to one side, then the other variable to one side. We are having V and T. So for me, I'm going to move this whole part on the right hand side to the left because it is something related to V. So I'm going to bring it over, become the denominator. Then I'm having a dV here. And I multiply the dt up, bring the dt to the other side, it will become dt on the right. And you can see very clearly now that we are having the variable separated clearly, all the v on the left, all the t on the right. Therefore, you can put the integration sign. So please take note for the dt here, right? There's a constant 1, right? And now we can integrate both sides separately. So for this fraction on the left, if we want to integrate 1 over 30 minus 0.01 V, we are having ln, and then 30 minus 0.01 V. And after that, I need to divide it by the differentiation of 30 minus 0.01 V. So I'm having negative 0.01 equals to integrate 1, I will get a t, and I group all the constant on the right hand side, which is a plus c here. Right, and then from this part, if I try to find out the constant c, given t is equals to 0, and the tank is empty, right? The pool is empty. Therefore, when t equals to 0, the volume inside the pool is also equals to 0. And if we try to substitute into our differential equation, our solution here, right? The general solution here, you'll see that c basically equals to ln 30 divided by negative 0.01. And of course, if I want to make it looks nicer, right? So I will try to change 1 over 0.01 become 100, then ln 30. This is my value of c. Okay, so after I get the value of c, I will make my equation become the particular solution, where it is actually equals to negative 100 ln 30 minus 0.01 v equals to t minus 100 ln 30. Alright, and then from this part, I will try to keep t on one side, and then I move all the other term to the other side. So this is basically what I get. Okay, so if you want, of course, you can further simplify. If you don't want, then you can just stop here to answer the next part of the question. Then maybe I want to make my calculation easier later, so I factorize out the 100. Then I'm having 30 divided by 30 minus 0.01 V. Okay, so for this step, basically I'm using the concept where ln A minus ln B can be simplified become ln A divided by B. Okay, so I'm using it in this step, and this is the differential equation, the particular solution that I get for this question. Okay, so we completed the first part, and now we solve the second part. So for the second part, they're asking what's the value for t when v equals to 1000. So when v equals to 1000, your equation of t will look something like this. We are having 100 and then ln 30 divided by 30 minus 0.01 1000. So from here, what we need to do is like we just try to simplify it. We are having 100 ln 30 divided by 20. And then from there, if you try to press calculator, right, and change your answer correct to 3 significant figure, then your t should be 40.5. And then the t is measured in units. Okay, let's have a look per minute, right? Okay, so it is in the unit of per minute. So the value of t will be 40.5 minutes. So this is how we answer the part number 2. Let's proceed further to part 3. As a part C here, they want us to obtain an expression for V in terms of t, and hence state what happens to V as t becomes large. Alright, so I will want to take back our particular solution again. So for the particular solution, after we get after we get it, we rephrase t on the left and then all the other things on the right, right? In part B, you can refer to my answer in part B. T can be written as 100 and then ln 30 divided by 30 minus 0.01 V. So now we want to rephrase our answer again here so that I will have the equation V equals to something something T. Okay, so first step, of course, we can take T divided by 100 and I'm having ln. Second step, you bring the ln over. When you want to bring the ln over, right, it is actually the log base E. So my left hand side, I'm having E power T over 100 equals to 30 divided by 30 minus 0.01 V. Okay, so another one. Next step, I want to bring the V up so that I can rephrase it, become the equation with V equals to something something T later, right? So I bring the whole denominator up and then I will bring down the E as a denominator. Alright, and after that, I'm having 30 minus 30 E power negative T over 100, which is equals to 0.01 V. So we are one step closer to the answer. Okay, so if I take the 0.01 over, I'm having 30 divided by 0.01, where it becomes 3000 minus 3000 E power negative T over 100. And of course, maybe I can further factorize the 3000 out, then I'm having 1 minus E power negative T over 100 here. Okay, so we already rephrased our particular solution for V in terms of T. Alright, and from here, what they want us to find is, they want us to state what happened to V when T becomes large. So when T becomes large, basically it means T is approach the positive infinity, right? Very, very large. And then for here, maybe we just need to consider what will happen to the function or to the expression e power negative t over 100 when the t is infinity. We need to roughly know the diagram of e power negative t over 100. So for e power negative t, by right, we are having something like this. It will pass through the 1. And then for your information here, the value of the graph, right, we're getting closer and closer to the x-axis when the t become larger. Okay, which means that when you're getting closer and closer to the x-axis, that means that the value for this graph become very, very small. So when you're having a value which is very, very small, we assume that it is equals to 0. So when we substitute t equals to infinity in the graph of e power negative t over 100, right, our value for this part will be approximately 0 because the value is very, very, very small, and therefore the V is approach the value of 3000. Because this one becomes 0, 1 minus 0 is a 1. Therefore, final answer for the t should be approaching the 3000 when the t is infinity. Okay, so this is how we answer question number. Okay, so the last question for this paper, we are given the function fx, and then they want us to express fx in partial fractions. Okay, so for the very first step, before we separate it into partial fraction, let's check and see whether this function belongs to proper fraction or improper fraction. If I have a look for the highest power of x, it is actually equals to 2. So the degree on top is a 2. And then if I multiply the x with x squared, we are having x power 3. So the degree for the denominator is equals to 3. When the degree of numerator is smaller than the degree of the denominator, basically this is a proper fraction. So for proper fraction, you can straight away expand it, become the partial fractions. Okay, so first let us write out the correct expression. If I want to rephrase this, become the partial fraction. Okay, so wait, I'm having 1 plus 3x squared. From here, you can see that you're having two factor. One is 3 minus x, another one is 1 plus 3x squared. So for 3 minus x, it is a linear factor, so I will just put a on top, and I'm having 3 minus x. And then for the second fraction, I'm having 1 plus 3x squared. So 3x squared, x squared is with degree 2. Therefore, for my numerator, I should have 1 degree lower, which is bx, and then plus c. Next one, I want to make all the denominator disappear. Therefore, I multiply my whole equation and every single term with 3 multiply, right, 3 minus x, and then 1 plus 3x squared. So when I multiply the whole equation with this fraction, or these two brackets, then my left hand side, I left only 5 minus x plus 6x squared. For the a, I cancel off the 3 minus x with 3 minus x. I'm having 1 plus 3x squared. For the bx plus c, okay, because the denominator has been cancelled off, therefore I'm having 3 minus x. Okay, so after we simplify our equation already, okay, become nothing do with the fraction, right? Okay, so we have make all the denominator disappear. Okay, we have cancelled off all the denominator, and then we are having a equation like this without the fraction. Okay, so we can start to find out all the constant a, b, and c. First of all, we will have a look for the linear factor first. So the 3 minus x basically is the linear factor. So I will want to make this linear factor become 0. So what I'm going to do is I will let x equals to 3. If I let x equals to 3, this whole bracket will become 0, right? And I want to substitute x equals to 3 into the whole equation here. So 5 minus 3 plus 6 times 3 squared. And for the left hand side, I will have the value 56. For the right hand side, 3 minus 3 becomes 0, and then I only have the term with the a. So 3 squared times 3 again is 27 plus 1. I'm having 28a. From here, very easily, I will get the value for a, which is equals to 2. Next value, if I want to find out the next value, I will consider this one. Okay, x is still linear here, right? So to make this x become 0, I will let x equals to 0. Again, substitute x equals to 0 into the whole equation that I show here. I'm having 5 on the left hand side. A is still the a. A is still the 2, right? Because we get the value of 2 just now for the a. And then 1 plus 0 is a 1. B times 0, you have no more. Then you are having a c here, and then with 3. 3 minus 0 is a 3. And if you try to simplify this part, basically you have c equals to value 1. Okay, so after I let x equals to 3, I let x equals to 0. To find out the last constant b, you can use any value that you never used before. So for my case here, I'm using x equals to 1. Substitute x equals to 1 into the whole equation. On the left hand side, I'm having 10. And then a is a 2. Multiply with a 4, I get 8 here. B multiplied with 1, I get a b. then c is a 1, and then 3 minus 1, I get a 2. And again, if I try to simplify from this part, basically I'm having the value b equals to 0. After I get all the constant value for a, b, and c, then I get my partial fraction. So it will look something like this. If I rewrite my answer again, sorry, there's a typo here, there's an error here, 3x squared, a is 2, and then there's no b, right? And my c is 1, so I'm having 1 over 1 plus 3x squared. And basically this is the partial fraction for this function. Alright, and now let's proceed to part B. For part B, they want us to find the exact value of integration function fx, simplify your answer. Okay, we can start here. To integrate the function fx, basically we need to use the result of the partial fraction that we find just now, which is 2 over 3 minus x, and then plus 1 over 3x squared plus 1. Okay, and now we can integrate it term by term. So integrate this one, the first term here, I'm having 2 as a constant, and I bring up the 3 minus x become ln 3 minus x. Then I have to divide the differentiation of 3 minus x where I get negative 1. And of course, I need to put in a limit for 1 and 0. And then for the second term here, before I do any integration, there are actually more than one way to integrate it. Right, so for me, I will rephrase it become square root 3x and then square, then plus 1. Alright, to integrate this, basically we are having the tangent inverse as an answer. But in general formula, okay, you have to rephrase your equation for this either in the pattern of ax squared plus 1. Okay, if you're having your expression in this part, it must be a 1 here, then you can replace it become the ax squared pattern. Then your answer for the integration should be tangent inverse, okay, tangent inverse ax divided by a. This is one way. Another way is you can also choose to rephrase it become 1 over x squared plus a squared, where you have to ensure that the coefficient of x squared is a 1. Then when you integrate it, you will have 1 over a tangent inverse x over a. Okay, so there are basically two types of solution that you can apply for this case. So for me, okay, I will rephrase it into the first pattern here, where it will be 1 over ax squared plus 1. Alright, so if I try to integrate this part, I'm having tangent inverse square root 3 over x, then divided by square root 3. Because my a is square root 3, right? And then I have to put in the limit for 1 and 0. For the first term, I try to take out all the constant first. And now I try to substitute in all the limits. So I'm having negative 2. Substitute the 1, I'm having ln 2. Substitute 0, I will get ln 3. Okay? And then for this part, I will take out the constant 1 over square root 3. Substitute the value x equals to 1, I'm having tangent inverse square root 3. If I substitute 0, I'm having tangent inverse 0. Try to rephrase the answer here. Okay, so I'm having ln, if I multiply the two in the equation, right? So I'm having 2 ln 3 minus 2 ln 2, and then plus 1 over square root 3. Tangent inverse square root 3. If you press calculator, you'll get 60 degree, which is pi over 3. Tangent inverse 0, you'll get a 0. Okay, and after that, I try to factorize out. So from here, right, there are a few ways that you can rephrase your answer. Either you are having ln 3 square, which is a 9, minus ln 4, 2 square is a 4, then plus 1 over square root 3 multiply with pi over 3. Okay, and then you can have ln 9 over 4, then plus, try to rationalize that if you want. So 1 over square root 3 can be written as square root 3 over 3. Eventually, you will see that you might have square root 3 pi over 9. Okay, so this is one way that you can rephrase your answer. Alright, we don't need to change it become decimal number or decimal places, because in this question, they actually did mention your answer should be in exact value. Okay, so if you want to rephrase, so this is one of the option where you are taking the 2, go back, become 3 square. This one, go back, become 2 square. And this one, you rationalize it. So when you rationalize 1 over square root 3, you can write it as square root 3 over 3. And when you simplify from there, this is the answer that you can get. So this is one way. Okay, or another option is, if you continue from this step, you can factorize out the 2 with a ln 3 minus ln 2. And again, for the 1 over square root 3, you change it becomes square root 3 over 3. Then I'm having pi over 3 here. Then ln 3 minus ln 2 can be rephrased as ln 3 divided by 2, and then plus square root 3 over 9 pi. So this is another way that you can show your answer. Okay, but no matter how, both answers are in the exact form. So you can see that they are in the ln and also the pi form. Right, so please don't change the answer become decimal places. You are lost 1 mark, as the question requests that we must have our answer in exact value. Okay, so basically this is how we answer the question 11, and we have finished discuss the whole question paper here. Alright, so thank you very much for watching this